Okay, good morning, everyone. My name is Braden McNeil. I'm the software trainer here at Waterloo Hydrogeologic. I'm going to be starting the course now. As you can see, you should be able to see up on your screen now the course title, Visual MODFLOW Transitioning from Classic to Flex. Of course, the topic of the short webinar today is really just discussing some of the major pinch points that anyone who's familiar with Visual MODFLOW Classic might have when they make that transition over to the new interface. Of course, yes, my name is Braden McNeil. Here's a picture of myself. I have a background in environmental engineering and applied geochemistry. Have been doing the training here at Waterloo Hydrogeologic for about 2 years now. I'm delivering the course today over GoToMeeting, and GoToMeeting does allow us to have a discussion and speak back and forth. But just so everyone is aware, I am recording the session today, and I will be posting it on YouTube. So with that in mind, I've kept everyone muted. I've kept the audio muted for now, but there will definitely be a time for questions towards the end of the session. There's also a chat box available within the GoToMeeting interface, and so if you have an immediate question, you can feel free to type it in there, and I'll answer some questions as we go as well. So, again, we're here to talk about the transition from the classic interface of Visual MODFLOW Flex to the classic interface of Visual MODFLOW to what we call the Flex interface. So Visual MODFLOW has been around for almost 20 years now. Almost 30 years now. Waterloo Hydrogeologic was founded in 1989 with a program called FlowPath. After about 5 years of development on that, we relaunched FlowPath, and at the time we called it Visual MODFLOW. And this was probably the interface that made our company what it is today. Visual MODFLOW, what we now call Classic, has had thousands and thousands of users all around the world ever since it was first launched in 1994. Now, the reason that we've made the transition over to Visual MODFLOW Flex is purely a practical one. Basically, the software development team here, just due to aging computer systems and aging development systems, it was becoming harder and harder for our development team to actually continue working on Visual MODFLOW Classic and to ensure that it would remain stable on newer operating systems and to develop new features and the like. So, yeah, about 7-8 years ago, we took the first steps to begin modernizing Visual MODFLOW. So we launched Visual MODFLOW Flex in 2012. At that time, it really was we might say it was a bit of a beta version. It didn't have all of the features and capabilities that Visual MODFLOW Classic had. But if you fast forward to today, we're currently on Visual MODFLOW Flex version 6.1, and you could say that basically back in 2018 is when we reached major feature parity with Visual MODFLOW Classic. And what I mean by feature parity essentially is just that the Flex interface is now able to support most of the engines and most of the features and capabilities that were available in Visual MODFLOW Classic over the years. So with that in mind, starting in 2018, we are sort of more confident in the retirement of Visual MODFLOW Classic. And again, the whole retirement of this Classic interface is purely a matter of practicality. The software is just becoming less and less stable on newer operating systems and actually isn't supported on Windows 10 at all. So again, the main reason why is it's primarily driven by the evolutions of software development systems and newer operating systems. So again, Visual MODFLOW Classic not supported on Windows 10, and we're not able to offer support for Visual MODFLOW Classic on these newer systems. And with that in mind, we obviously always want to continue to improve the software and support our clients, and so that's why we're making this transition away from the Classic interface and towards the Flex interface. We've obviously been at this for several years, and this has been our plan for quite a while. And so what we're doing now is we're really trying to ramp up our efforts to ease that transition for our clientele away from the Classic interface. And so that's why we're delivering this free webinar today. The main points of the webinar today are going to be basically to introduce you to all of the background about why we're retiring Visual MODFLOW Classic, And then to give you a bit of a primer, a brief introduction to the Flex interface, introduce some of the major structural differences between the two interfaces, introduce you to some of the new features that Flex has that wouldn't have been available in Visual MODFLOW Classic, and that type of thing. So before we get into discussing Visual MODFLOW Flex, I thought I would just spend a bit of time basically going over the roadmap of what the Classic retirement schedule looks like. So in January 2015, we actually released Visual MODFLOW Flex version 5.0. And that version of Visual MODFLOW Flex at the beginning of last year actually achieved major feature parity with Classic. And again, what that means is that all of the major flow engines and contaminant transport engines that have been available in Classic are now fully supported in Visual MODFLOW Flex as well. So once we had made that final step with Visual MODFLOW Flex, we actually spent a little bit of development time trying to build a more stable version of Visual MODFLOW Classic, and that was actually released in April of 2018. So there is, it's not really a new version of Visual MODFLOW Classic. It doesn't introduce any new features or anything, but what we did is we took one last attempt to try and achieve as much stability as we possibly could on newer operating systems. So even though this version of Visual MODFLOW Classic was released after Windows 10 became available, that doesn't necessarily mean that Visual MODFLOW Classic, this version here, is supported on Windows 10. It isn't, but it is the most stable version that we can provide. So starting in April 2018, this is when we sort of officially began the process of retiring Visual MODFLOW Classic. So here it says that VMOD Classic and Flex will continue to be bundled for 1 year. So the actual truth is that if anyone who's purchased Visual MODFLOW ever since VMOD Flex was released in 2012, that person is actually eligible for both interfaces. Both VMOD Classic and VMOD Flex can be installed and run on a single computer using a single license. So that's actually the case still to this day. If you were to buy a license today, Visual MODFLOW Classic would also be bundled up with Visual MODFLOW Flex. The original plan was that we would unbundle those sometime in 2019. We actually haven't done that quite yet. So as of right now, they are still available together. I'm not exactly sure when that unbundling will happen, but just so you know, if you look at the note down here, VMOD Classic will still be available for purchase pretty much indefinitely, but we won't be able to provide any technical support for it. So if you really do like Visual MODFLOW Classic and want to continue to use it as long as possible, what we would recommend is trying to find yourself an older computer that has maybe Windows 7 or 8.1 installed, and try to air gap it or disconnect it from the internet. Microsoft has been going through and forcing Windows 10 updates, so you would have to basically find a way to mitigate that or prevent that Windows 10 update from occurring. So again, that's something you'll have to speak with your IT teams about, but suffice it to say that Visual MODFLOW Classic will still be available into the future. It's just going to have very limited technical support available for it. In April of 2020, that is our firm date for ending technical support for VMOD Classic. What that means, again, is that we will basically no longer be addressing technical support issues for VMOD Classic through our technical support team. The program will still be available, and if you are able to get it installed on an older computer, you probably will be able to do that without any issues. But again, moving forward, there's just going to be some practical restraints on actually using that license. So what we're here to do today, of course, is to help you to make that transition from VMOD Classic to Flex. Just because, again, Flex is going to be the more stable product on newer computers. So here's what the schedule of the course today is really going to be about. I'm going to introduce the various engines and grid types and flow packages which are supported in Visual MODFLOW Flex. There are some new engines and grid types that are supported in Flex that were never available in Classic, so we'll do a brief introduction to those. Then, very importantly, we'll talk about how you can import Visual MODFLOW Classic projects into the Flex interface. What will be imported, what will not be imported, what steps you'll have to take, and considerations that you'll have to keep in mind before beginning that import. At that point, we're going to move towards some topics that are sort of new to VMOD Flex. We'll introduce the conceptual modeling workflow, which isn't something that was ever available in Classic. We'll briefly discuss some of the changes to the PEST workflow in VMOD Flex. We'll also talk about using data objects, surfaces, polylines, polygons. This is really what Visual MODFLOW Flex has been designed for, is trying to make it possible for you to use all of the data objects that you have available to you. We'll talk about how to manage multiple models and grid types within a single Flex project. That's not something that was available in Classic. In VMOD Flex, a single project file can actually contain multiple conceptual models, multiple grids, and each of those grids can contain multiple model runs associated with them. And then I'll briefly introduce some small new features to VMOD Flex, and then, of course, at the end of the course, I'll provide you with a number of different resources that you can review on your own time, tutorials and video files and that type of thing, so you can, familiarize yourself with the Flex interface on your own time. And of course, you can always contact me if you ever have any questions. All right, so without any further ado, let's get into some of these topics here. So, first of all, this slide here just shows a bit of a history of the MODFLOW code itself. And as you can see, there have been many different engines and transport engines and secondary packages that have been released over the years. Down here at the bottom, we have the major flow engines, and up here at the top, we have mostly contaminant transport engines and secondary engines. Now, a lot of these different engines will be familiar to you VMOD Classic users, but some of them might actually be new to you. So the reason I show all of these and the history of the MODFLOW code is basically just to show that Visual MODFLOW Classic development pretty much ended somewhere in this range here, and therefore there's going to be a few things that are not available in Visual MODFLOW Classic, which we have had time to introduce into the Flex interface. So the first main thing that you'll need to determine or select whenever you're building your models is which flow engines you're going to use. So this slide here just basically illustrates which flow engines are supported in the two interfaces. So as you can see, Visual MODFLOW Flex has support for pretty much everything that Visual MODFLOW Classic had support for, with the exception of MODFLOW 96 and the Modular Groundwater Optimizer. Now, the reason that we have not introduced these two engines on the left over to the Flex interface, and I can tell you right now that we will not be introducing these engines, I can pretty confidently say that we're not ever going to introduce these engines, and that's simply because they've been superseded by newer, better engines. So MODFLOW 96, basically MODFLOW 2000 and MODFLOW 2005 have superseded MODFLOW 96. There isn't really any great use cases or great scenarios where you would want to use MODFLOW 96 as opposed to MODFLOW 2000 or 2005. And therefore, we're gonna have our development team focus on more pertinent, and better features. With MGO, the Modular Groundwater Optimizer, there actually have been some new packages that have been released. The name of the package escapes me right now, but that is on our product roadmap, so we do plan on introducing, at some point in the future, a different engine which will essentially replace MGO. But again, this engine has been superseded by newer and better engines, and therefore, again, we're going to focus our efforts on those newer and better engines. Now you'll notice that some of these flow engines that are available in Visual MODFLOW Flex have never been available in VMOD Classic. So those include MODFLOW USG and MODFLOW LGR. And actually, the fact that we have a few additional flow engines supported in Visual MODFLOW Flex speaks to the fact that we'll actually have a few additional grid types that are supported. So in Visual MODFLOW Classic, you're pretty much, your VMOD Classic only supported the regular finite different grid types. So you would be restricted to grid types similar to these ones with, global refinements. Now with Visual MODFLOW Flex, since we do support MODFLOW USG and MODFLOW LGR, allows us to support a few additional grid types. So here on the bottom left, we have an image which shows basically a MODFLOW LGR grid. LGR stands for Local Grid Refinement. What Local Grid Refinement allows you to do is it allows you to actually embed multiple child grids within the greater context of a parent grid or a parent model. So that's what these smaller colored areas are. These are actually child grids embedded within the greater parent model. VMOD Flex also supports a few workflows for MODFLOW USG. So it is actually possible to generate finite element meshes, as well as for MODFLOW USG, we've got two grid types supported, Voronoi grids and quad tree grids. So the real benefit of having these grid types is primarily around having more efficient discretization around these irregular model elements, for example, meandering rivers, or basically any model edge that isn't straight. So there's lots of benefits to the regular finite difference solution methodology. It's open source. It's been used for a long time. So there's many secondary options, such as secondary transport engines and that type of thing. But the main drawback of this typical finite difference method is that it has very inefficient discretization, and your anisotropy has to align with the grid. But with the finite volume numerical method solution technique, which is what is available through MODFLOW USG, it's basically just a generalization of the finite difference methodology for any type of grid that doesn't necessarily have to have 6 neighboring cells. So it's also open source, developed by the USGS, provides you with all the refinement flexibility that you would have from a finite element mesh. The solution methodology is very similar to finite difference, so it's not something that's extremely difficult to communicate with stakeholders. And yeah, it provides you with that excellent grid refinement. So that's one of the major benefits of Visual MODFLOW Flex compared to Visual MODFLOW Classic, is the ability to work with these new engines and new grid types. Now, with respect to contaminant transport engines, there are also a few engines that were available in VMOD Classic which have not made it over to the Visual MODFLOW Flex interface. And again, I'll be frank, these engines probably will never make it over into the Flex interface. So PHT3D is a multi-component geochemical speciation transport model. Allows you to perform, well, basically mineral speciation modeling. We found that PHT3D had a very small user base, and therefore, again, we have to sort of make a value judgment as to how we want our development team to spend their time. And PHT3D simply didn't have a large number of users, and therefore, we've kind of prioritized other development tasks. MT3D is a pretty great contaminant transport engine, but we've found that, again, newer contaminant transport engines have essentially superseded MT3D99 or have filled in the gaps, and they essentially provide similar or very similar capabilities. So when it comes to the reaction models, you can see, these MT3D99 and PHT3D are listed here on the left. We do support RT3D in Visual MODFLOW Flex at this point, which provides the largest selection of different contaminant transport applications or reaction models. And therefore, again, it sort of supersedes some of these other engines that are available in Classic. We've got a similar slide here for the retardation models. And again, as you can see, MT3DMS essentially provides all of the capabilities of MT3D99, which is why we're not in a huge rush to introduce MT3D99 into the VMOD Flex interface. So to make a short story of these two slides here, it's essentially that we do now have contaminant transport engines in Visual MODFLOW Flex, which essentially provide all the capabilities of the transport engines that were available in VMOD Classic. The last thing that I should note is with respect to various flow packages. In Visual MODFLOW Flex, we have made a big effort to try and support almost all of the packages that were available through Visual MODFLOW Flex. We've got them all listed here on the right-hand side. There is a short list of packages that we did have available in Visual MODFLOW Flex which are not yet available in VMOD Classic. They're listed right here: the evapotranspiration segment, streamflow routing, and the multi-node well packages. Now, we do have plans to introduce these packages into the VMOD Flex interface as soon as possible. Hasn't been completed yet, but it is on our roadmap. So the important thing to consider when comes from transitioning from VMOD Classic to Flex is, well, first you're going to want to make sure that all of your existing projects from VMOD Classic are going to be usable within the confines of the Flex interface. So this information here becomes extremely important, as does the information regarding which contaminant transport and flow engines are supported in the various in the two interfaces. So if you ever want to import a classic project into Visual MODFLOW Flex, the first thing that you're going to have to do is essentially take a review or make a review of your VMOD Classic project, just to ensure that essentially there are no unsupported components within that project, or rather no packages or engines that are used in the project which aren't supported in Visual MODFLOW Flex. So we'll talk a little bit more about what to do in those situations in just a minute. In terms of how to actually initiate the import process, it's extremely simple. Within the Flex interface, you're just going to, from the main menu, you'll click File, Import Project, and that will open up this window right here. What you'll do then is you'll click on this button here to open up a file explorer. You'll browse to the location of your Visual MODFLOW Classic project file and select it. You can then enter a new project name. By default, it will be the same name from your Classic project. And then you can also specify where the new VMOD Flex project should be saved. When you click Import, essentially you should just see an import log appear, which will go through the model one piece at a time, basically importing property zones, boundary conditions, etc., etc. It'll show you a helpful little import log, and it will identify if there are any problems during the import procedure. Whenever it's finished, you should see basically a message that the model import has finished successfully, and you would just click Close at that point, and then you would have basically a working Visual MODFLOW Flex project. Now, there are a couple of things that will not be imported, primarily the model results and the translation settings. So when you import your model, the grid, the property values, the boundary conditions, all secondary optional components as well, mod path particles, zone budget zones, observation data, that should all be imported without any issues. However, you'll have to revisit the translation settings, retranslate your input files, and rerun the model. So your translation settings and your outputs, they don't get imported along with your Classic project. But again, after you've imported the project, it's just a simple matter of updating these translation settings and retranslating and running the model. Everything else should be imported correctly. It is always important, though, that you review the model. The import process is not 100% effective every single time. It works generally very, very well, but it is very important that after importing the project, you spend a bit of time just reviewing the model to make sure that there hasn't been any mismatched units or anything like that. And then, again, spend some time after having translated and run the model to compare the results with your VMOD Classic project. Something else that's important to consider, sort of a important structural difference between the Classic and the Flex interface, is how transport boundaries are assigned and how they're tracked. So in Visual MODFLOW Classic, you would assign all your transport boundaries separately. So you would have a constant concentration boundaries, your recharge concentration, evapotranspiration, and point source concentrations. In the context of Visual MODFLOW Flex, the moment that your model is converted from a flow model, or the moment that transport is activated, every single boundary condition within the project implicitly becomes a concentration boundary. So all of your flow boundaries will sort of have a new concentration component added to it. The only exception is for constant concentration boundaries conditions, since those don't include a prescribed flux. But otherwise, as soon as you activate transport within the VMOD Flex interface by clicking this checkbox right here, then whenever you access any of your boundary conditions, in addition to the regular attributes, so for example a recharge rate, and for a recharge boundary, you'll also see a concentration attribute. Now, initially, the default value will be -1, which simply means that the concentration is undefined. Now, what that means is that if the boundary condition is a sink, then the concentration of water leaving that boundary condition is essentially adopted from the concentration within the cell itself. As soon as you specify a value of 0 or greater, then that boundary condition will actually become a true sink or source. Now, if the model that you're importing is all supported, there's no unsupported packages or flow engines or transport engines, then in that case you would simply click File and then import the project, and everything should be imported without any other issues. However, if the model is based on an unsupported flow engine, for example MODFLOW 96, or if it's got an unsupported transport engine or potentially an unsupported package, what do you do then? Well, if it's an unsupported flow engine, then what you'll want to do is open the project in Visual MODFLOW Classic and simply update the flow engine to one of the newer ones, one of the newer flow engines that has superseded MODFLOW 96, for example. So you could update the flow engine to MODFLOW 2000 or 2005. You would then basically retranslate your files, save the project. You can then close the Classic interface, open up Flex, and at that point you should be able to import the project without any issues. So it's simply a matter of converting that MODFLOW 96 project to a MODFLOW 2000 or 2005 project using VMOD Classic. Now, if a Windows 10 update has come along and has essentially made it impossible for you to use Visual MODFLOW Classic on your computer and you're not able to open the project and update the flow engine, then there does exist some other tools which you can use outside of the interface, which will allow you to convert all of the raw MODFLOW input files. So the USGS has developed what's called the MF96 to 2K conversion tool. So if you're ever in this situation and you're not able to actually open up Visual MODFLOW Classic, just feel free to reach out to us and we can walk you through the process of running this conversion tool here. Now, if the project from VMOD Classic is based on an unsupported transport engine, like PHT3D or MT3D99, then you'll have to, things are going to get a little bit more difficult. If the project is based on PHT3D, well, at that point there essentially is no equivalent engine available in the Flex interface, and so you'll need to find some way to continue using Classic. Again, this is going to be a difficulty for you because we're going to stop offering technical support for Classic. And so if this does apply to you, if you do have several models that are based on PHT3D, feel free to reach out to us and we can have a discussion on how to best maintain that VMOD Classic license into the future. Again, we're not going to be able to 100% support you throughout that process, but we can certainly provide you with some tips and tricks on how to sort of maximize the lifespan of that license. Now, if the transport model is based on MT3D99, then MT3DMS or another contaminant transport engine might be a suitable replacement. So in that case, you'll want to review the original user documentation for the various contaminant transport engines and just see if there's any compatibility basically with any of the other supported flow or transport engines, primarily MT3DMS. It may require a little bit of manual editing of the reaction or the sink source files, but again, if you ever find yourself in this situation, feel free to reach out to us and we might be able to provide some guidance. Now, if the model itself has some of these secondary unsupported engines like MGO, then in that case, again, it's similar to PHT3D. There's no equivalent in Flex, so you'll want to continue using Classic. Now, there is one final case here where your project might have an unsupported package, such as the streamflow routing or the multi-node well package. In that case, Visual MODFLOW Flex has a feature called the Advanced Translation Settings. I'll discuss the Advanced Translation Settings in a little bit, but essentially it's a new feature that allows you to actually incorporate unsupported packages. So that also requires a little bit of manual work and editing of the text files, but I'll briefly introduce that feature a little later on. So there is a mechanism where you can actually incorporate unsupported packages. Now, in our experience, based on our usage statistics, there's a pretty small portion of models that fall into either of these categories of being based on MODFLOW 96 or based on these older transport engines. In our experience, most models and most modelers have transitioned to some of these newer engines, and so we anticipate that you won't have too many major difficulties whenever you're importing your classic projects into VMOD Flex. But of course, if you ever do run into any problems, we are here to help you, and we would definitely want you to let us know so that we can improve the import procedure for future clients as well. Now, again, I want to just point out that we haven't been able to introduce every single feature and component from the classic interface into the Flex interface at this time. Practical constraints make it impossible for us to, just to go from 0 to 100% sort of support for all the classic features. But our entire development process is driven entirely by client feedback. And so if there's anything that you ever experience, any difficulties you experience with an import process or using the Flex interface at all, or if there's ever any features or capabilities that you had in Visual MODFLOW Classic that you'd like to see in Visual MODFLOW Flex, please let us know. We've recently built directly into the Flex interface a couple of feedback buttons, these thumbs up and thumbs down buttons. They're available throughout the entire Flex interface at all times. So anytime that you encounter anything that you like or dislike, please leave us a bit of feedback. These buttons, they are actually context specific, so it kind of logs the last few things that you've done. So it provides us with a little bit of context on what it is that you were doing whenever you had that positive feedback or that negative feedback to provide to us. And again, our whole development process is driven by this client feedback, and we haven't got a gigantic user base, and so you may actually find that your feedback goes a long way with us. I will just make one additional note about this feedback though. It is anonymous, so see there is a little message down here. If you're ever experiencing any technical issues, a bug or an error that you need us to help you with, then don't notify us through this particular mechanism of these thumbs up and thumbs down, because this feedback is completely anonymous. If you do experience any actual bugs or errors, then what you'll want to do is send an email to our support team, support@waterloohydrogeologic.com. Okay, so that's basically how to import a project into VMOD Classic. It really is just a matter of reviewing your Classic project for any incompatibilities, and then as long as the project is supported, all the components and packages are supported, it really is just a matter of a few clicks. At this point, I'd like to start introducing some of the new features of Visual MODFLOW Flex that would not have been available in Visual MODFLOW Classic. And the single biggest advancement from the Classic to the Flex interface is the introduction of the conceptual modeling workflow. So in Visual MODFLOW Flex, we actually support two workflows, the numerical and the conceptual modeling workflow. With conceptual modeling workflows, you essentially build a conceptual model that's completely grid independent, and then at the end of the conceptual modeling process, you define a grid, and then you simply merge the two together. And then on the other side of the conceptual modeling workflow, you essentially will have a fully functioning numerical model. And you can actually use that conceptual model to spin off multiple different iterations of your conceptual model using different grids, different grid types, and that type of thing. So again, the whole idea with the conceptual modeling workflow and with the Flex interface as a whole is that we want you as a modeler to be able to fully utilize all the different data objects that are available to you. When MODFLOW was first designed, there wasn't necessarily the ubiquity of different shape files and surface data files, and there just wasn't as much data as there is nowadays. So with Visual MODFLOW Flex, we want you to have sort of the full capacity to make use of all of these different shape files and surface data files and that type of thing. So in VMOD Flex, we have kind of a very robust data importer that allows you to do a lot with your data objects. So this is the general model development process in a nutshell. Typically you'll start by building yourself a conceptual model, which might actually be, in a digital model built in GIS or something like that, or in Visual MODFLOW. But typically the actual modeling process, or where you would initiate Visual MODFLOW Classic, is down here in the numerical modeling side. Once you've find your conceptual model to be suitable, then you'll build your model grid. Then you'll assign boundary conditions and model parameters on a cell-by-cell basis before running the model, and then going through the process of calibrating and validating it. With the conceptual modeling tutorial, we've essentially pulled these few additional steps into the Visual MODFLOW interface. So the advantage of the conceptual modeling workflow, or the disadvantage of the traditional numerical modeling workflow, is that you have to basically generate the correct grid or mesh before you begin assigning properties and boundaries. After the grid or the mesh has been modified, then you typically need to recheck and rework a lot of those input elements for your different property locations, property zones, and boundary conditions. So generally, that may not necessarily be easily done. You may have to delete them and reassign them. So the classical modeling workflow here in a nutshell, you begin by defining your grid, then you import some data, assign property zones, boundaries, inactive zones, etc., all on a cell-by-cell basis. If you do refine the grid, then you typically have to rework a lot of these steps. Now with the conceptual modeling approach in Visual MODFLOW Flex, you define the conceptual model boundary and all model inputs completely independent of any numerical grid. And then you can design actually as many different grids as you want. You can design multiple finite difference grids, multiple MODFLOW USG grids, both Voronoi grids and Q grids. You can create a few phi-flow meshes, and then based all on the one single conceptual model, you can quickly and easily convert that conceptual model to 5 or 6 individual instances of your numerical model with different grids. So in a nutshell, here's what the conceptual modeling workflow looks like. You define your conceptual model completely independent of any grid. Finally, you define the model domain and create a grid, merge them together, and finally run them. If you wanted to start again with a new grid, you would basically be able to skip past all these initial steps, go straight to creating a new grid and then just merging it again with your conceptual model. So in Visual MODFLOW Flex, the entire interface is designed around the idea of workflows. And even though the VMOD Flex interface does support this conceptual modeling workflow, if you're more familiar with the traditional numerical modeling workflow from the classic interface, that is also supported here in the Flex interface as well. Of course, the look and feel of the interface will be completely different, but the general numerical modeling workflow of creating your model grid and then defining properties and boundary conditions and observation data and zone budget zones and particles on a cell-by-cell basis, that is, of course, also supported. So here's just a bit of information about navigating workflows. Essentially, they're arranged in a logical order, so you won't be able to proceed from one step to the next until you've, basically provided some minimal level of information. So in the conceptual modeling workflow, these are the steps that are available. Now, later on, in about 20 minutes from now, I'm going to show you a few different places where you can find additional tutorials and exercises. So I'm going to be running through these slides extremely quickly, and it might be a little bit confusing, but I just want to give you a very quick introduction to what the conceptual modeling workflow looks like and how it feels. I'll point out several places where you can find more information about all of this in about 20 minutes from now. But this is what the workflow for conceptual modeling is in a nutshell. You start by defining your modeling objectives, which is what this screen looks like here. Defining the modeling objectives simply entails selecting the flow type and determining whether or not transport is going to be active in your model. At this point, you're able to select various retardation and reaction models that will be applied. That, of course, is going to inform the various property arrays that you'll have to populate with different property values like decay constants and distribution coefficients and that type of thing. At this stage, we're also going to set the model start date, and in the conceptual modeling workflow, we would then move on to the next step, which is to import data. Now, the conceptual modeling workflow is oriented completely around data objects. It's not very visual at all, and so we've provided this step here early on so that you can get all of your data objects sort of imported and ready to go. But it is possible to actually import data at any time. So if you want to import data, it's going to open up an import data window. I'm not going to go through the whole process ad nauseum, but suffice it to say that these are the supported data types and formats. You can use points, polygons, polylines, all sorts of different shape files in VMOD Flex. Surfaces, wells, the well data objects, these are simply imported from an Excel data file. Maps, DXF files, and 3D gridded data. And you can see all the different formats here on the right-hand side. As a fallback, you're pretty much always going to be able to work with Excel files, text files, but we've made an effort to support the most common data formats that you're likely to have available to you. After you've imported the data, it will all appear up in the data tree. If I back up a little bit here, in terms of the main components of the interface, the data tree is on the top left. This is simply a spot for data objects that will be the building blocks of your model. Down here on the bottom left is what we call the Model Explorer. It's sort of a branching tree and node structure which essentially contains the structure of your entire project. So the Model Explorer can actually contain multiple conceptual models and each of those conceptual models can contain a number of different numerical grids. Each of those grids can have a number of different model runs underneath it, etc., etc. We'll talk about that in a few minutes. In the middle here we have the Workflow Navigator, which is essentially a roadmap to help you navigate through your project. And then on the right-hand side is the main working window, which is going to look different depending on which workflow step you're on. As you can see here in the Define Modeling Objective step, it looks like this. This is what it looks like for importing data. In any case, once you've imported all of your data, it appears in the data tree, and those data objects can then be used to build your model. It's also possible to create new data objects and to interpolate surfaces directly in VMOD Flex. So if you have a map and you want to use that map to digitize various polylines which delineate your river, for example, or the locations of ponds and wetlands, you can do that directly in the Flex interface. And you can also interpolate surfaces, so if you've got a bunch of different well logs with the contact points between your various soil units, you can import those in as point data files and then interpolate your data surfaces, which would be used to create your conceptual model. Not going to go over, again, the process for creating surfaces, but suffice it to say that it can be done in VMOD Flex. Once all of your data objects have been imported and or created, you then move on to the first step, the first real step in the conceptual modeling workflow, which is to define the conceptual model. Here all you're going to do is provide a name and a description for the conceptual model. Then you'll use a polygon data object and load it into this field right here. The polygon data object represents the outside edge of your model. Then you would click the Save button, and then that will start to flesh out some information in the Model Explorer. You then move on to the next step, which is to define the model structure. Essentially what you're doing here is you're specifying a number of various horizons, which represent the contact points between the major soil units within your model, and you use surface data objects to define the locations of those horizons. You'd also specify horizon type as either being erosional, conformable, base, or discontinuity horizon, and based on the horizon type, VMOD Flex knows how to treat the horizons if and when they ever intersect with each other. And you would then click on the Create button. Essentially, these horizon rules, they allow you to create 3D structural objects based on the input of just these surface data files. Okay, so when you click Create, it creates these structural zones, which again are just 3D objects. The next step is to define property zones. And what we're doing there is we're essentially taking those 3D structural zones and we're just associating property values with them. So we're, again, essentially taking a 3D object and we're saying that it has kx, ky, and kz values of whatever we define. So we can define these property zones in a number of ways, but essentially it all just, the main thing is we're just, again, applying property values to the different structural zones within our model. Now, as you go along, the various structural zones and property zones, these can be opened up and reviewed in a 3D viewer anytime you like, just to make sure that the structure is what you expect. Finally, we'll define our boundary conditions. Again, this is all done using data objects. There is no grid at this point, and so we're not going to be able to identify individual cells. When we click on the Define Boundary Conditions button, we first have to specify the boundary condition type, and then we again would apply a data object. We would grab a polyline from our data tree, for example, and load it in here, which in this case would describe the location of a constant head boundary, for example. In this image here, we're defining a river boundary condition. So after you click, you specify the location of the boundary and you click Next, then you have to specify the attributes for those boundary conditions. And the attributes can be constant values, or we can use a number of different data objects as a data source. So if I wanted to say that the stage of my river is equal to the ground elevation, I would simply change this value from constant to use surface, and then I would click on the From Surface button and load in my surface data file. So that's what's shown right here in this image here. In this example, it's for applying a drain boundary condition. We would say, let's use a surface, and then we would click on the From Surface button. We would grab our surface data object, load it in, and then click OK, apply our remaining attribute values, and that would essentially be it. Now it's kind of hard to visualize what's happening here again because there's no drawing tools involved in assigning these boundary conditions. It's all done using data objects. It's also possible to apply boundary conditions to the side of the model, in which case an interactive 3D window would be available, which would facilitate us basically selecting the side of the model where we want that boundary condition to be applied. Once we've applied all of our boundary conditions, and at that point we essentially have a working conceptual model, we would simply have to create one or more grids and then merge them with our conceptual model. So I'll go through this relatively quickly, but essentially we can create finite difference grids here, specify the number of rows and columns, the vertical aspect of the grid, and when we click Finish, we would then be able to refine that grid at the next step. It's also possible to create unstructured V-grids, which would be done it's all done based on an automated algorithm, so essentially the VMOD Flex interface will identify any data objects that were used to build the conceptual model, and then based on a number of settings which are related to the triangle algorithm, we would specify what those settings values are, we would click Generate, and then a Voronoi V-grid would be generated automatically. We would then just click Finish, and that V-grid would then be available to convert to a numerical model. We've recently also added in the ability to create Q-grids or quad tree grids. If we click on that button, then it would open up this interface window right here. Essentially, we can choose, basically based on the data objects, again, that were used to build the conceptual model, we simply click on the Refine button and any cells that contain that data object would be refined. Kind of like going from this image here to this image here. And again, once we're happy with the final Q-grid, we simply click OK. That Q-grid will then appear in the Model Explorer down on the bottom left, and we can then convert that conceptual model, that pre-existing conceptual model with our new Q-grid, and the end result is a working numerical model, which we would then just have to translate and run the model files. So that's the last step of the conceptual modeling workflow, is to select from your available grids and then simply click on the Convert to Numerical Model button. A conversion log opens up which tells you property zone by property zone, boundary condition by boundary condition, how the conversion is going. And when you click Close, what you'll see then is that a new tab will open up with a numerical modeling workflow. And under the Model Explorer, you'll see basically the entire structure of your MODFLOW, of that MODFLOW model has been fleshed out. So as you work with multiple grids and multiple model scenarios within a single project, you'll see under the Model Explorer that there's going to be an awful lot of basically an awful lot of data objects shown in there. It's important if you're new to VMOD Flex just to be aware that there will be a lot of duplicated data objects in here as well. For example, you can have multiple conceptual models. Those will just be named. Typically, if you don't apply any names, custom names, then each new conceptual model will simply have, a higher number. So conceptual model 1, conceptual model 2, unstructured grid 1, unstructured grid 2, run 1, run 2, etc., etc. In any case, in a single VMOD Flex project, you can have multiple conceptual models. Each of those conceptual models can potentially have multiple grids associated with them, and each of those model grids can potentially have one or more model runs associated with them. So the model runs are simply individual instances of a numerical model with the associated grid type. So run 1 here and run 2, they may have different property values, for example. And then under each model run, you'll have a full branching structure of the model explorer, which has all of your different property groups, all of your different boundary conditions, all of your different observation data, etc., etc. So as you experiment and become more familiar with VMOD Flex, just be aware that the model explorer can actually contain potentially dozens and dozens of individual models. And it's important to be confident when you're navigating with the Model Explorer so that you don't accidentally, edit the boundary conditions for a model run that you had previously finalized. Similarly to in the Model Explorer, if your project itself contains many different instances of your numerical models, then the project folder itself is going to be the same way. Within the project folder, you should have a single directory or a single folder for each individual project. Each individual project will have multiple folders for individual conceptual models. Individual grids under those conceptual models will have their own folder as well, etc., etc., etc. So just to quickly summarize, conceptual modeling is your basic high-level representation of the system that you're modeling. In VMOD Flex, you can build a conceptual model which is completely grid and simulator independent, and that will be the foundation for one or more numerical models. So you can create one conceptual model, and then you can generate 5 or 6 different grids and merge them all together very quickly and easily, and it allows you to test out a number of different iterations of your model under different conditions. So the conceptual modeling workflow, again, is kind of designed to provide you with the most use out of your data objects as well, which is something that is completely different from the VMOD Classic interface, where primarily everything was done manually. Now, in the numerical modeling workflow, which I discussed earlier, and I'm not going to spend any time really introducing it, but it basically takes the traditional approach of creating your grid first and then applying boundary conditions and the like after the fact. Now, that is still possible, and it is also, we have also facilitated the use of data objects within the numerical modeling workflow as well. So for example, if I have a data object, a polyline which delineates the location of my river, I can assign a river boundary condition using a data object, and then I would simply select my river data object and load it in to describe the location of that river. And I would then assign my attribute values to whichever cells have been identified by the data object, and the end result is that you would have a boundary condition at the location of that data object. You can do the same thing with property zones, of course, and it's actually, you can do more with data objects as well. If we wanted to use a data object, for example, again to describe the river stage, that is potentially something that we could do. So in a similar vein, if we were to apply our conductivity using a data object, we would first load in a polygon data object which delineates the actual locations of our new conductivity zone. And then we could also use a surface data object as the method for defining the actual conductivity values within that zone. The end result would be something like this, where we have a distributed array of conductivity values. So again, even though VMOD Flex does support the traditional numerical workflow where things are done on a cell-by-cell basis, you still have the ability to try and make the most out of your data objects within that traditional numerical modeling workflow. And in terms of assigning properties and boundaries using drawing tools like the classic interface, that's definitely also possible. You can assign conductivity zones or boundary conditions using polylines, polygons, selecting single cells, apply boundaries or property zones to the entire active layer, row, or column, etc., etc. Now, there have also been several really helpful new tools that have been introduced to the Flex interface that were never available in the classic interface, and I'm just going to do a very brief introduction to 3 of them here: the scripting tool, the expression builder, and the advanced translation settings. The scripting tool or the scripting tab is essentially it's a tab that displays the inner language of commands that Visual MODFLOW Flex actually applies internally. So as you edit a boundary condition, for example, you'll see all of your boundary condition values on a cell-by-cell basis. But if you access the scripting tab, what you'll see is essentially the inner commands that are being fed to Visual MODFLOW Flex. Now, this is a type of tool which I'm guessing is very helpful to people who have been using Visual MODFLOW Classic for a long time. If you're used to Visual MODFLOW Classic, then it's very likely that you're pretty comfortable manipulating data within text editors. So if you're ever having difficulty getting something done using the tools that are available within Visual MODFLOW Flex, we've sort of exposed the inner script so that you can quickly and easily copy all of this content out into Notepad or Excel or anything you like, really, make some changes manually, and then paste your changes back into this interface. And then when you click OK, you would be able to, for example, if this, based on reading what I'm seeing here, I know that this is the editing of a constant head boundary condition. In the interface itself, it doesn't allow me to easily copy this down from layer 1 to layer 3. I mean, there is a copying tool, but it doesn't allow me to edit the existing boundary condition and move it down to layer 3. I would have to copy it and then delete the existing one. If I wanted to do if I wanted to just simply copy this down to layer 3 instead, what I could do is copy all of this out and then replace these 1s with 3s and then copy it back in. That way I would be doing 2 steps, in one. I would be basically deleting the boundary condition in layer 1 and moving it down to layer 3 simultaneously. So the scripting tool, again, it just basically exposes the inner script of Visual MODFLOW Flex, and it isn't something that you necessarily have to rely on at all, but it can be very helpful, and it's not very hard to understand what these commands are actually telling Visual MODFLOW Flex to do. So it's something that's potentially very, very helpful. We also have implemented something called the expression builder or the field calculator. And this field calculator or expression builder functionality is available anytime that you're editing a property zone or a boundary condition. All you would do is click on the little button, the X or the square root of X button, and that would open up something like this window right here. On the left-hand side, we can see that there's a whole bunch of variables and constants, and these are actually cell-specific variables. So if I ever needed to correct a boundary condition by the interfacial area of a cell, and my model domain, or my model rather, has very irregularly sized grid cells. There's a number of different refinement zones. Rather than going through cell by cell and figuring out what the interfacial area of each cell is, I could simply use the expression builder and build an expression that automatically corrects some variable based on the dx and dy of the individual cell itself. We can also use data objects as well. So if I ever wanted to apply, again, a boundary condition where let's say the drain elevation is equal to the ground surface minus 5 meters or something like that, I could simply use the ground surface data object minus 5 meters using these variables here, and that would build an expression which I could then apply to all of the cells within the edit boundary condition window. So again, any time that you could imagine where it would be helpful to have a calculator that uses cell-specific variables, whether it's the volume of the cell, the length of the cell, the width of the cell, the interfacial area of the cell, any variables associated with that cell, then you can use the expression builder to do that. So this, again, is extremely helpful in situations where you need to make kind of intelligent changes to your model, rather than figuring out, what the exact cell height or cell elevations are on a cell-by-cell basis, and then having to do a bunch of manual data manipulation to figure out what your boundary condition value should be on a cell-by-cell basis. VMOD Flex can do all that heavy lifting for you now. So this expression right here would apply a constant head boundary condition value which is equal to essentially 5 meters below the top of the cell elevation. So you can use this hashtag bottom, that's the cell bottom elevation, plus the height of the cell minus 5 meters. That's always going to give you 5 meters below the top of the cell. So lots and lots of different applications for this expression builder. And finally, we have the advanced translation settings. I mentioned this earlier. The advanced translation settings essentially is a method for you to incorporate packages that are not actually supported by Visual MODFLOW Flex. Now, just because Visual MODFLOW Flex isn't able to actually create that input package, that doesn't mean that the background MODFLOW engine won't be able to actually run the package. The MODFLOW engines that are run in Visual MODFLOW Flex are just the same as all of the other MODFLOW engines that the USGS publishes. They're the exact same, and therefore if the USGS version can do it, then obviously it can also do it through VMOD Flex. The question is just whether or not VMOD Flex is able to actually create the input file. But if you're ever, if you're an advanced modeler who's comfortable in manually generating those input files, then what you can do is you can basically access the advanced translation settings within the translation menu in VMOD Flex. You would change the run flag for any unsupported package to yes, and then even though the translate package, the translate setting will still be equal to no, we can still indicate to the MODFLOW engine that it should run that. So, for example, if you have a VMOD Classic project that does use the ETS package, you could import everything about that model except for the ETS package. You would have to make some manual changes to the ETS package and save it into your input file, and then just change this run flag to yes. Then you would retranslate your input files and then run the model. So again, it's just a methodology for you to kind of manually help Visual MODFLOW Flex to actually run packages that Flex doesn't support. So that's just a brief introduction again to some of the new things in Visual MODFLOW Flex. I would point you now to just several additional support locations where you can continue to learn more about VMOD Flex. So first of all, on our website, we do have the VMOD Flex support page. So if you go to waterloohydrogeologic.com, and then you go to Products, Visual MODFLOW Flex, and then Support. This is where we're going to host most of our helpful support resources, including free tutorials and free video tutorials as well. So under that support page, there is a VMOD Flex tutorials page as well. So that would be this link right here. So if you're interested in learning more about the conceptual modeling tutorial, I highly recommend this tutorial right here. If you're completely new to Visual MODFLOW Flex and you'd like a bit of a walkthrough of the traditional methodology of running through the sort of a regular numerical modeling workflow, then I would recommend starting with this contaminant transport modeling with MT3DMS tutorial. But we also have tutorials which talk about the pest workflow in VMOD Flex, how to import projects and MODFLOW datasets, etc., etc. And then I'll also point out that we have a video tab here. And if you visit our YouTube channel, we actually do have a wide variety of video tutorials. So these conceptual, there's a video tutorial which goes through the entire conceptual modeling tutorial. There's also a similar playlist that will go through the entire numerical modeling tutorial. So I highly recommend, again, if you're new to VMOD Flex, maybe spend 40 minutes or so and review some of those resources. I do, of course, also host regular training events. I have a monthly introductory course, which is a half day for VMOD Flex. It's about $350 to attend. Or if you buy a new license, typically we do include that training for free. I do actually have a session of that course on Wednesday of this week, and I'll have another one I'll host another one in December. I do that every month, so. I do host advanced courses on occasion as well, so I do have one scheduled in March. So if there's ever any need for additional Visual MODFLOW Flex training, we're definitely here to help you. We have tons of different resources that you can access, and of course training events that you're more than welcome to attend as well. So that's the end of the free webinar today. The takeaway is that we, unfortunately, due to practical constraints, are forced to retire Visual MODFLOW Classic. Technical support for Visual MODFLOW Classic will continue until next April. After that, there's going to be very limited technical support. The Classic interface will still continue to be available for purchase, but again, due to just practical limitations of the way that computer systems are advancing, it will be harder and harder and harder to use that. And with that in mind, Waterloo Hydrogeologic is going to be focusing all of our future developments on VMOD Flex. The Flex interface, we've made an effort to try and reach parity in terms of what Classic and Flex can do, but in fact the Flex interface has many additional benefits over the Classic one. Our development process is driven entirely by you, so as a Classic user, we are definitely very interested in hearing how we can make this transition easier for you. So please leave us feedback, and we will do our very best to incorporate all of your requests into our development cycle and try to make this transition as easy as possible. So I'll thank you one more time for joining me today. I'll open the class up. If there are any questions, feel free to ask them now. But otherwise, thank you one last time, and we hope that the transition from VMOD Classic to Flex is as painless as possible for you.